Okay, so we're back. I hope that didn't hurt your heads too much. Oh, there we go. So this replaced dx with a half du. We need to sort the limits as well. I'm still laughing about falling over. Can we? Oh no. This is the worst video I've ever recorded. At least it's in the top 10 bad videos. We're going to change these limits. So if u equals 5, x equals 5 over 2, sorry. U would be, well, if you put 5 over 2 in there, we get 0. 2 times 2.5 is 5, 2 times 5 is 0. Brilliant. If x equals 3, we get 6 minus 5, which is 1. So this is between 0 and 1. This is all looking great now, isn't it? We've got a nice thing happening where this half and this 2 are going to cancel out, leaving us with the integral from 0 to 1 of u to the 8 plus u to the 7 du. Let's go with that. That's now nice and easy to integrate. U to the 9 over 9 plus u to the 8 over 8 between 0 and 1. We sub in the limits, giving us a 9th plus an 8th minus 0. Right. No, it's an 8. A 9th plus an 8th is, well, that's 8 plus 9 72ths, which would be 17. That was 72. Oh, that's only the answer we were looking for. Great work. So that was 5 marks. And it was once you've got the substitution done, it was all right, wasn't it? But that was quite tough. And this bit was quite awkward, wasn't it? Trying to work your way through that. Great. Everybody okay? Right.
Good.
Question 2.
What do you get the marks for in that one?
Doing it right.
Yeah, but there's 5 marks.
Yeah. Well, where should we give them? You're going to get a mark for rearranging your u equals to get du by dx, so you can do your substitution. You're going to get a mark for sorting out the rest of your substitution here and being able to replace the 4x minus 8. So 3 marks if you ended up with this bit there. The 4th mark for actually doing the integration of that. And the 5th mark for putting in your limits correctly and showing that it is equal to 17 and 72. Does that sound alright? Brilliant. Right, now we will do question 2. Find the exact value of this integral, the integral of x squared e to the x dx. Now this is with 2 things multiplied together, and we've not particularly got one thing that's derivative. We could probably have a go at doing this either way, actually. We could maybe have a go with the substitution, but it's wanting us to do it by parts, really. The thing that gets nicer when we differentiate it is x squared. The thing that doesn't get worse is e to the x. So we're going to let u be x squared, and dv by dx is e to the x. So when we differentiate u, we get 2x. When we integrate e to the x, we still get e to the x. So our original integral becomes u times v minus the integral, that's between 0 and 1, isn't it? Minus the integral between 0 and 1 of v du by dx. So we start off with that, but we need to do integration by parts again to deal with this bit. So now we're going to let u equal 2x as we keep going. dv by dx again is going to be e to the x. So du by dx is 2, v is e to the x, and so our integral as we go forward with this is still our x squared e to the x between 0 and 1 there, And then the next bit of the integral, which we're taking away, is u times v, sorry, which is 2x e to the x, between 0 and 1, and a big bracket around that, minus the integral between 0 and 1 of v du by dx, which is now 2e to the x dx. So we've got the bit that we had, the u times v from the first bit by parts, and then our second integral there, we've used integration by parts again, which, let's try and tidy this up a little bit now. We've got x squared e to the x in there. We're taking away 2x e to the x from that bit, and we've got minus minus, so plus 2e to the x, which is what you get if you integrate 2e to the x, and the limits were between 0 and 1. So now we're ready to sub in our limits to get our exact value, which will be 1 times e minus 2 times e plus 2e minus, and if we put 0 into there, x squared e to the x gives us 0, minus 2x e to the x is 0, plus 2e to the 0, which is 2. And so at the end of all that, we've got e to the 1 minus 2. We don't need to put the 1 there. And there's our answer.
How come when you integrate 2e to the x, how come we don't know it's... Couldn't it be e to the 2x as well? Because when you...
that'd be 2e to the 2x if you differentiate it.
No, because when you differentiate e to the 2x, you get 2e to the 2x.
2x. Okay. Right. So again, we've got to our exact value of e minus 2. Everybody happy?
How many marks was that?
6.
And that's
Tick in
maths.
random places. Oh. Go. Still going.